just downloaded ADS and now you'd like to get up and running in under 10 minutes. Here's how. In this short video, you will learn how to navigate through the ADS environment to create a new workspace, build a new schematic, and run a simulation. Through an example, you will also learn how to tune your design to optimize the performance. You can use ADS with me along the way. I'll be using ADS 2016, but what you learn in this video will generally apply to all previous releases. So let's get started. When you start ADS, you will first see a Getting Started screen. There are many helpful resource links on this page to explore if you're interested. Let's close it for now and go ahead and create a brand new workspace. A workspace is how ADS organizes your design. Click on the new workspace icon and follow the on-screen prompts. Let's give this workspace a name and set up a few more parameters. This is the point that you will decide, are you going to work on an analog RF domain, DSP domain, or will you be doing something that requires library parts from external sources? If you are doing IC design, you may need foundry parts from foundries, and if you are doing board design, you may need components such as capacitors and inductors from component vendors. We're just getting started, so I will accept the defaults. This is an important choice if you're doing a layout design, but for now, we're just going to keep the default choice and click Next. Great! Now the workspace is all set up, and you have a blank ADS workspace open. Let's start building our circuit. You typically build in schematics, so here's how to create a schematic window. It can be helpful to use the wizard, but let's ignore that for now. Here's the schematic window in the middle and library palette on the left. From the palette, you can place components on your schematic. In the beginning, most people will be in the lumped component palette. You can place resistors or other components on your schematic by using a left click. Your mouse is the main tool here. Click grabs the component from the library. The escape key stops any commands, so each time I grab a component, I can keep placing it to the schematic until I hit the escape key. A right click pans the view and the mouse wheel is used to zoom in and out. Now let's start building a simple design. For example, building a low-pass filter. We start with the capacitor. The capacitor by default is going to be horizontal. Press Ctrl R or use this icon here to rotate the component. Let's put an inductor in the middle. And then wire the rest of the circuit. To do so, click the wire icon from the main toolbar menu. Now this low-pass filter schematic is complete. Let's look at the filter performance. Typical RF designers want to check their filter performance in the frequency domain, so they look at the S parameters. Let's do it together. To do so, I need to run an S parameter simulation. In order to run this simulation in ADS, you always need to have the simulation controller somewhere unconnected on the schematic. Note that for this example, the simulator will control the frequency. You can find the simulation parameter controller from the S parameter library palette. If I connect it up this way and run an S parameter simulation, num1 is going to be port 1, which is the excitation point, and num2 is set for port 2, which is the measurement point. Great! The setup is complete for the S parameter simulation. I left everything at default, but you can change it if you want. Right now the capacitor and inductor values are 1 picofarad and 1 nanohenry. The frequencies that I am simulating are from 1 GHz to 10 GHz in steps of 1 GHz. These steps are too wide, so I'm going to change the step size to 10 MHz. Notice that I can also double-click the components on the schematics and make changes in the dialog box. You may notice that there are multiple ways of achieving the same task inside ADS. Here we are. We have a simple design and S parameter controller. To run a simulation, this gear symbol should be your go-to button. There's a gear here, and there's a gear on the simulation control that we place on the schematic, and that's how they connect to each other. Click Simulate. By default, ADS opens up the status window, then a data display window. Right now there are no problems, so the simulation completed in less than a second and a blank data display window opens. To plot data, I can look at the S11 in the Smith chart. This is my Smith chart icon. Click here. From the pop-up menu, select S11, click Add, click OK. That is S11 on the Smith chart. An ADS Smith chart is a great visual representation of the data. Now let's look at the filter performance, which is typically S21 on a rectangular plot. Click the rectangular plot icon. From this menu, select S21. Click Add, and it will say S21 is a complex number. How do you want to plot it? As you know, complex numbers cannot be plotted on the rectangular plot unless you do some work beforehand. ADS can do this for you. Select to convert complex values to decibel and go ahead and plot the dB of S21. As you can see, lower frequencies between 1 GHz and 7 GHz are passing through the filter and higher frequencies are attenuated, and that looks like what we expected, a typical LPF filter performance. We just covered the basics of building schematic capture and looking at data. Now that you've completed a basic design, we can learn more about ADS. ADS is a design tool, which means changes are very easy to do and don't cost you anything. Whereas if you actually built this filter in the lab to change the value of your capacitor for better performance, you would have to go buy one, desolder it from the circuit, and solder something else. A lot of work. In a simulation environment, this can be done by a quick edit and simple click to rerun the simulation and view the new results. You don't even have to keep resimulating after each change. You can use an ADS feature called tuning. This is the tuning fork icon. If you click the tuning fork icon, you have several options on what you can tune and see how it affects the results. So let's go ahead and look at it. You can see tuning this component value will change the cutoff frequency. For this filter, I can tune it to go to roughly 6.2 GHz, or I can change it to go to around 7 GHz, where its performance starts getting worse. I can do the same thing by changing the inductor. So you have many different design options. The tuning feature is a fast way for you to learn how your design behaves and what values impact your performance the most. That's it. You can now use the tuning feature. I'll go ahead and cancel this tuning. Click I do not want to update, and it will go back to the default that I had before I started the tuning session. In this short video, we learned how to place parts on the schematics, set up simulation parameters, and then run a simulation to be able to see results. Plus, we got a sneak peek into the power of tuning. These basics are a great start for anybody who is new to ADS, and pretty soon you'll be able to take full advantage of its potential.